Oh my gosh. You just
Okay,
see
now
Navi like posing.
Hey, poser.
I am a poser.
He really just went there.
How are you guys? Guys and lady. I can only see a few of you.
Yourself?
Guys and lady.
And Ashley. Guys and Ashley.
Guys and dogs.
It's just Nathaniel, GP, and Ashley. That's all I can see. Oh, there's a bunch of you. Okay. Hey, guys and ladies. I just couldn't see on my computer. Oh, yeah, everyone's here. Cameron, that's an adorable picture of you as a little kid. It could not possibly be anyone else. Right? There is no other Cameron. That's really funny. Most people, as a little kid, they just look like an anonymous creature. It could be anybody. Just assign whatever name to them, and that's them. Cameron, your little kid picture is exactly you.
Thank you.
It was meant as a compliment. Sort of a neutral one, but a compliment. Are you guys, what'd you do for your long break? Oh, this doesn't just happen. Man, I'm tired. Are you guys, is anyone as tired as I am?
No.
Okay, Ashley is. Yeah, lady is. Lady is as tired as I am.
Always tired.
All right. Yeah, JP. Yeah, I think you have. I've never met somebody so exhausted as you. I am one part sympathetic and one part envious that you can sort of collapse into sleep with that exhaustion at inopportune times. I have a hard time sleeping when I'm not.
I'm getting so good at it because I used to do it in class all the time,
There's character. There's character when you fall asleep. Sometimes when people fall asleep, they're assholes. I'm like, oh, come on. This is good material right here. And they fall asleep. With you, it's always like I'm touched. Like you feel so comfortable in that setting that you're willing to sleep. There's almost something sentimental or touching about JP sleeping. I don't get that feeling when other people sleep.
There's this one semester when I was taking I was just having the worst workload, and I fell asleep in a GE class, and apparently for 5 minutes the whole class was staring at me, including the professor, and just watching me sleep and snore.
That's funny.
And then it wasn't until one of my friends nudged me after 5 minutes of this observation when I woke up, and they just continued going back to normal, and I was like, well, see, that was rock bottom at that point for me. But
they're soft rocks.
Yeah.
It reminds me of how your mom reads you a bedtime story.
Mm-hmm.
It's has to be a good story, otherwise you don't fall asleep.
If it's too good of a story, you're absorbed.
Yeah, but then I fall asleep in Gen Bio, and that's always never a good story. So
I use Audible every night to fall asleep.
Nice.
There are some books that I'll be up all night listening, and there are other books that are just so bad that I can't. You have to assign the right amount of attention. It has to be entertaining but not riveting, and it has to be informative but not critical to your knowledge base. I mean, there's this middle ground in everything, and it just sends you right into slumber as though I'm 5 and mom's reading. But yeah, there are particular books that have to be used,
like the Holy Bible.
Actually, for a really long time, I was using Anna Karenina, and that was a really good sleep aid for a year. I never finished it. It was just so boring. I'm sorry, if you like Anna Karenina. I never saw the movie. Maybe the movie's good. The book was just horrible with good writing. I mean, the quality of the writing was good enough that I could focus on the writing, but the story was just so boring.
You get a letter from HR, so you don't like Vladimir Nabokov. Hey.
But then there's people that there's times where you should be awake, but they're kind of assholes for not waking you up. One time I knocked out during the physio test, and the professors were staring at me, and they did nothing. It's
during the test.
Yeah, during the test, I was knocked out, and it's I feel like if you saw me, you'd kind of wake me up. What are you doing?
Hey, I'd nudge you a little bit.
Yeah.
The answer to that one is B. Why? Keep moving. Yeah.
Yeah. Instead, they just kind of looked at me and they're like, "Yeah, this blonde is fucked."
That's just unkind.
Yeah. I was just why would you not wake up your student during an exam? And then no one else wants to do it because they're gonna get accused of cheating. As everyone else.
Yeah. What life conditions had you falling asleep during a physio test? Was that you were up all night studying?
I think it was just this really bad time in my life, and then on top of that was the course load was heavy, lacking sleep in general, then lacking sleep from the exam. So then at one point, actually multiple points, I would just knock out and then like frantically wake up like, oh shit, the exam, right? But like the professors would be like staring at me but not be doing anything. And it's kind of like, so do you want me to fail? Like
So yeah, life is stressful. Welcome to Stress Fizz. Like, I think we can use that as our intro. And I'm probably gonna have like food on my teeth the whole time. Okay. Chat box is open, but feel free to unmute and do whatever the whole time. So Genevieve, Genevieve, are you here yet?
I am here, but
well,
I will also be gone in like 10 minutes, but then I'll be right back. But I'm here.
Okay. Okay. So we're going to talk about the actual tissues and the time course of adaptation, a little bit about the tissues, a little bit about signaling proteins, and a little bit more about the time course. We're not digging any deep holes yet. We're still just sort of raking the dirt. We're just scratching at the surface still. So we're not delving anywhere. Yeah, but again, I'm going to start the lectures just so you're aware of what I mean. If you've had me before, you know I do this, but so you're aware of what information I regard as more important or more foundational, or this is the stuff you should remember tomorrow and a year from now. These are the things that are a little bit more helpful to fill your pockets with. And the other stuff is just sort of conversation, or it is context, or it is a way of remembering stuff that's on here. And some of this is just a way of remembering other things, like sun exposure, good or bad. Well, sun is a stressor, right? And yeah, it's bad if you live in Florida or California, right? And if you're a dermatologist, you're not going to be a successful dermatologist in Alaska, right? You're going to be a successful dermatologist in the South or Mexico or something, wherever there's like a ton of sunlight. That's where you're going to be a successful dermatologist. But on the opposite side of that, you need some sun exposure in part as a stressor to get the stress response. It's not all just about vitamin D, and squats and broccoli and even potentially tobacco. Just these things. It's exercise is good for you because it's bad for you. That would sort of become a cliche because I've just said it so many times. And there's infinity stressors, right? The world has infinity stressors because everything is a stressor, and in the absence of that thing is a stressor, right? Food, you're eating too much X, Y, or Z, too much protein, too many calories, too much fat, too much of some vitamin, to eat a bite of polar bear liver, oh, you're going to die. And too much vitamin A. Or the absence of things, these deficits, scarcities, that's a stressor. So the presence and the absence, those are both stressors of everything. So there's like infinity stressors. And I don't know how I'm going to do the test, whatever, but just having this be the frame, the foundation with which you understand this material. 1980 to 88, Baltimore radiation, right? So that was the experiment that they didn't publish right away because they didn't find what they were hoping to find. What they were hoping to find was radiation kills, radiation maims and disables and kills, and nowhere in their results did they find that. They found radiation was bolstering health. Why? Because we get the stress response, right? We have terrible immune systems if you live in a clean room all your life, and then life comes and kills you as soon as you encounter it. As soon as you are confronted with real life, which is filthy, you die because you don't have a good immune system. And so you don't want to have the clean room version of life. And whether that's sun exposure, whether that's broccoli, don't wash your broccoli. I mean, if we're talking, pesticides, that's a slightly different topic. There isn't like an amount of pesticides that I would say is healthful. There's an amount where you're not going to notice deficits or upregulate aromatase enzymes. That's what converts testosterone, androgens, estrogens, and there's doses that aren't going to hurt you, and then there are doses that are bad. But in my understanding of the pesticide, atrazine. If you look up atrazine, not atropine, the drug, but atrazine is the pesticide that is on every kernel of corn and whatever. I'm unfamiliar of a dose that is somehow helpful, but there are minimum doses that are harmful. But what I'm saying is most things that are harmful, small doses, they tend to be helpful, and even radiation. Now, if you go up in outer space, you're going to have these like high energy particles flying through you. You're being, that's one of the stressors in outer space, is not just microgravity. There's a bunch of emotional stress associated with it, but then there's also a bunch of radiation, really high levels. So I mean, we probably shouldn't buy organic fruits and vegetables, right? The whole pesticide stress, for example. I think the organic stuff is going to have a little bit of more natural, coming from nature, meaning natural, if without the existence of human intervention, it would exist just the dirt and bacteria and bug poop and everything on it that your immune system can deal with. The pesticides are usually some enzyme inhibitor or upregulator. They have particular metabolic interactions that are going to kill flies and then just like convert males into females and stuff. So I it's like saying, is there a dose of, I don't know. I mean, because like even stuff, the caffeines and nicotines of the world. I mean, these are pesticides, but they're nature's own pesticides. So some pharmacological is there a dose of ibuprofen, let's say, Cox blocker, right? Cyclooxygenase inhibitor. Is there a dose of ibuprofen that is helpful, like a stressor? I don't think so, because you're just changing enzymatic functions in the body in a very specific way, and like, now we have the lipoxygenase pathway is upregulated, right? So we're asthmatic. So I don't think with drugs, with pharmacological drugs, this isn't something I've thought about before this moment. So maybe I'm totally wrong. I haven't done laps on this thought or reading on it, but outside of nature, when we get into the pharmacological, compounds, I think a lot of stress physiology starts to break down because you're just overriding weird, enzymatic reactions, and it's like aspirin is a suicide inhibitor, meaning irreversible of cyclooxygenase, and is that a stress response that we're going to respond positively to in a tiny dose? Oh, take your baby aspirin. I don't think so. And I don't think baby aspirin is really helpful anyway. I think the dose is too small to get the effect that people want out of it. But so I think there are exceptions when I say expose yourself to stress. I think open up the medicine cabinet and just start swallowing stuff. That's an exception to what I'm saying. I think. I'm not sure. I would have to do some reading. I'd have to do some more thinking, walk some laps with some thoughts. But what nature is filled with stresses. Nature is determined to punish and exterminate us, and subjecting ourselves to that sort of environment, to that sort of abuse of Mother Nature, not a kind Mother Nature. I mean, that is an abusive mother. And subjecting ourselves to that belt once in a while. That's an insensitive thing to say, but I think you get what I'm saying. But now, laboratory may have exceptions to stress physiology, because evolution could not anticipate the invention of chemistry labs, right? Evolution had no idea that hypodermic needles and whatever cc's of drugs are filling those needles. We didn't really have a way. Biology didn't anticipate that. So there are exceptions to the constructed pharmacological universe, I think, to some of the stuff I'm saying. But fitness, and make sure you know all these terms, right? Homeostasis, stress, toleration, habituation, sensitization, accommodation, adaptation, and then genetic adaptation, and then fitness, right? What fitness means. And then these are the names that are helpful to know. It's boring, I realize, that some of these names of like, it's just some like black and white guy. Like, why do I need to remember a black and white guy? But it's foundational, and it's funny, it's like when I turned 30 is when I started reading memoirs. And I asked Van Ness, and we had a conversation a long time ago of when did you start reading memoirs? And I don't know what his answer would be today. I mean, this is right when I first got here. I was 35 and I'd been reading memoirs for 5 years. And he said something similar. Oh, I was like 30 years old. You just start reading memoirs at 30 of here's what I've done with my life. Let me see what other people did. Maybe they made better choices than I did. They probably made better choices than I did. And which is why they have memoirs that, sell and people care about their lives, is they made like ethical, good, progressive decisions. If you're black and white, your progressive decisions are like heinous compared to today's ethical standards. But you get the idea of what I'm saying. History suddenly becomes fascinating when you're in your 30s. And these are some of those major historic names: Mario and Luigi, right? 1985, at least for the US version. I think it was like 83 and for the Famicom. But so we have Davis, right? Henry Gassett Davis, and he was flexibility. He was stretch a ligament or other soft tissues, right? Quote unquote. And then we have Wolff's law, which is looking at bones, and stress a bone, apply a very specific load to a bone. And both, I mean, this is 1892, this is 1867 over here. These are old. These are really old names and research and experiments and writings. And then down here, we're in the middle here, we have Hans Selye, 1930s. Generalities, right? So we have GAS, general adaptation syndrome, vague, ambiguous adaptations. All stressors are sort of the same to a degree. And the acute response, he was onto something. He was very smart. He was onto something, but he wasn't really on where that road deposited us was inaccurate. The road he started on was delivering us somewhere articulate, somewhere reflective, somewhere honest and true. But he just plowed ahead on this road. Like, he missed his exit. He totally missed his exit and just kept going into the 50s, And so this is Thomas Delorme in the 1940s. Thomas Delorme was the weightlifting, right? He's a surgeon. He's like a World War II doc. But looking at, let's repair our soldiers. How do we do it? Let's get them on that bench press. I mean, that's it sounds like a gym coach version of stress phys or adaptation, but it was brilliant. And then my favorite, Edward Adolph, he really did a lot of the testing and just said, all right, let's look at altitude, let's look at cold, let's look at heat. He just started looking at these diverse contexts and measuring all sorts of things. So this is really specificity of adaptation. This is like, oh, I noticed a thing about bones over here, right, Luigi? Oh, I noticed a thing about ligaments, Mario. Here's some stuff about how to lift weights, right? Thomas Delorme. And I'm insane, right? Super smart. He was super smart. He deserved the exact number of Nobel Prizes he won, though, which is to say 0. So Edward Adolph, just remember when this is in the 1950s, and he's saying it has been widely supposed that adaptations to various stressors have much in common. He's referencing Hans Selye in a way that does not betray scientific and social etiquette there. And just everything, there's overlap, but everything's individual. There's some overlap, but the individuality of it all, the specificity of it all, is really what's critical. I had to look up how many spiders there were. I just assumed there's like infinity species of spiders, so I looked it up this morning. 45,000 is according to National Geographic. Now, I didn't even click on pages. I didn't go to any links. This is as far as I went. I spent 5 seconds so I could have like real information, something close to real information. Like, oh, National Geographic, that's close enough. That's reputable, I guess. So how many species of spiders are there? I Googled, and then this was in the box and it said National Geographic, so I used it. So the only point, because I'm not going to ask how many species of spiders. I don't care. I'm like, arachnid, bio or whatever. That's not my thing. My thing is species diversity. Why? Right? why is there diversity in these? Why do we not have one version of a spider? Well, climates differ. And depending on the heat, depending on the altitude, depending on the humidity, depending on the terrain, depending on predators, depending on, bug life, whatever that movie was, A Bug's Life, depending on depending on all of these things, the spider is going to be different, right? The environment comes first. The environment first, the species second, adaptation second. In this case, for species differentiation, we're looking at selective pressures that are going to influence survival, or sexual selection, but who cares? Survival. Lots of people care, but for the context of this class, who cares about that piece? So just remember, you don't need to know this guy's name. I mean, I haven't read his books. I assume they're poorly written. I think he probably spent all of his time. I doubt he was like reading books and stuff. Who cares? I don't know. Maybe he's a wonderful writer. I never gave it a chance. But I thought this was a brilliant passage, which was the intro to a different book. And this concept that he presents, I like his concept. There are no two stretches of terrain, of geography. It's sand today, sand tomorrow. They're different mounds of sand or expanses of sand. If you've taken philosophy, like as a GE philosophy, and just like all the old, like Cradulus, if you guys remember him, where he said, my sweater today is not my sweater tomorrow. I put my foot in the river or the stream or something today, and I put my foot in that same stream tomorrow, and it's a different stream, right? So that's sort of old Cradulus philosophy, and that's really what he's saying here, but he's just making it more compatible with look outside, go for a walk, walk around campus, walk on a lawn, avoid some like Stocktonian, hoodlum or something. And whatever your experience is in one day, it's not the same the next day. And then that David Byrne, don't remember his name either, but that concept of what creates a genre. Well, you have to have an environment, right? You have to have the music hall, you have to have the stadium, you have to have the SUV, you create an environment first. And there's research on birds in San Francisco, right? This is San Francisco. So birds in San Francisco, and tracking what they do with their little larynx, right? With their laryngeal nerve. And how they do those songs to compete and fit in San Francisco's sort of ambient noise, those city noises. And so it stresses everything, right? Stresses every possible thing, every single moment of this guy's life, stress. And his body was figuring out how to deal with it. The birds are experiencing different kind of audible stressors, and the drivers are having their road rage or whatever. And so the body, I'm going to use the word designed a lot, and I'll have a little caveat about what I'm talking about in just a second. But you're very conservative. You're super conservative. And in my bodybuilding, this isn't me. In my I didn't lose my tattoo that says lust or just, or I can't tell what it says. But this guy, just because he's good at bench press, that doesn't make him good at monkey bars. That doesn't make him good at rope climbing. Specificity of adaptation. And if you I'm going to go do some incline bench in a weird way with people hanging on the bar, now I'm good at everything. Okay. So this is from World's Strongest Man, Eddie Hall. Okay. So Ross, you know who this is, and Eddie Hall, he must be do you know what his tattoo says? you are familiar with the gentleman. But so if this exercise or that exercise of some familiarity, I'll agree, or this exercise or doing this, if you got huge, if you look like this and you hollow out your boat, and then suddenly you look like Eddie Hall, right? Your resting metabolism is enormous. You're probably not going to catch that many fish or antelope or find that many roots to eat. Right? You're not going to find or trap or kill enough food to support this, right? You need to really put in your time and continue to eat to assure your body that, okay, I get it. Every time you're eating 10,000 calories a day and doing all this work, I give you permission to be huge. And so the pink dumbbells, that's not going to do it, because if you lift pink dumbbells and your rent goes up and then suddenly you can't pay your rent and you're homeless, and like we said in whatever last lecture or something, like homeless in a body means your body is dying. So we're very calibrated. We're designed or calibrated. Tattoo says the beast. That's a little like a vanity license plate. That's too self-flattering. I disapprove of his of his tattoo, unless he's been #1 in the world for 6 straight years, and as a celebration of year 5, he accepted. He's like, okay, here's a poll to all of my fans. You tell me what my tattoo is, and everyone else says the beast. Okay, and he sort of like, I guess I have to. Then I would approve. So the body is designed. There's a nice passage. This isn't something you need to remember or anything about this, but when physiology, when we're talking about design, often what we're talking about is this selective pressures calibrating. And so Katie Bowman, I'm going to come back to her title. She's not a good titleist. Move Your DNA. That's not a good title. Wonderful writer though. Wonderful writer. And it's easier when writing about the body to write the hip is designed to carry the weight of the torso than to write a consequence of the hip and pelvis orientation as the hip has become robust enough to carry the weight of the torso. So designed or calibrated by the stresses. The stresses are an environmental context, and the body is going to adapt at the level of the individual, and if it's selective pressures that would exterminate you otherwise, at the level of the species. So the reason we are so conservative, the reason we are Scrooge, let's say Scrooge McDuck, as opposed to the Charles Dickens version, we are the like Scottish Grandpa Duck, and our unwillingness to spend a penny more than we have to is, especially if we're trying to become an Eddie Hall, it's just so expensive. Now, this is a high estimation right here. 75% of a cell's energy budget is protein synthesis. That's a high estimation. It's not totally unreasonable. It's just a little bit higher than some people are estimating. But the point is, and I'll show you some more studies and estimations. The point is, it is super expensive to translate proteins, to hypertrophy a tissue, to make your tissue grow, right? Super expensive. And so in this study, they're looking at the order, this what is the most expensive and then the least expensive? What's the most expensive thing? Protein synthesis, right? And then, synthesis of RNA, DNA, and then sodium cycling, and then calcium cycling, and proton lead. And so in order, what's the most expensive thing? Protein synthesis. And, let's get into trouts and let's look into different organs. It's not just linking together. There are other components here that are ringing up the bill, here. There are other components, but this is a look at, let's look at the liver compared to the GI tract, really high percentage of protein synthesis, and the kidney and the heart, and and so it just depends on what you are, what organ you're, where you are, and it depends on what you're doing at the time too. How much you're eating and what your behaviors. I mean, so this is a contextual breakdown. But if you think in general, let's just say it's half. Let's say it's half. There was that estimation of 75% earlier. This one, it's 30 to 50%. This is a third, a half of the cell's metabolic expense is making proteins. And adaptation, what is the bulk of adaptation? Making proteins. That's the bulk of adaptation. Maybe it's the extracellular matrix. Maybe it's actin and myosin. Maybe it's enzymes. Enzymes are proteins. Maybe it's transporter molecules. Maybe it's receptors. Proteins do everything in the body. Adaptation is a bunch of proteins, right? Your proteins are changing. And again, this could be muscle hypertrophy, or it could be let's increase oxidative enzymes. All right, well, how do we do that? We have to translate a bunch of proteins. These enzymes are proteins. So that is going to be adaptation. Is the bulk of it is going to be a bunch of translation, and translation is just the most expensive thing in your budget. This is your rent. If your rent, let's say your rent is $2,000 a month, or let's say it's $1,000 a month. Let's just make it easy and even. And let's say you live by yourself and it's $1,000 a month. And let's say you make $1,600 a month or something. Like, that's, you have $600 left to spend on everything, food and entertainment and all of your utilities and your gas. But rent, that's the most expensive thing. That's protein translation. That's right. So if people want to lose weight, you want to go on a weight loss program, start translating proteins. That's what's spending all your calories, is protein translation. It's not like, oh, let me go for a walk and use up, let me just drain the budget a little bit. I'm going to go for a 20-minute walk and drain my budget. Not as effective as protein translation. That's just sort of metabolic expense for use. That's sort of acute use. If you want long-term effects, go translate a bunch of proteins. I mean, this is go be a sprinter, not a endurance walker. So now the time course of all of this, the sequence of adaptation, is going to be accommodation. And they're like, what the hell? Why do you keep making me do this weird pull-up thing? I have never once come down with an apple in my mouth. You go up and down, and there's no prize at the end. What the hell, right? And so the body is like, this must be important though, because you're doing it all the time. You're doing your pull-ups, or you're doing your shuttle runs, or you're doing your whatever it is. You do this thing so regularly that it's threatening the integrity of my myotendinous junction or my bones, or even metabolism. So cardiovascular health, my essence is being threatened by your behavior, by your repeated behavior. I guess I have to adapt. I've been just tolerating and accommodating with a bunch of sweat and sort of neural permissions and whatever for like a week now, for 2 weeks now, for 3 weeks now. It's time to start spending those calories. I guess I have to do this. So I better buck up and pay my dues. I better get the gym membership now. I'm using it so frequently. So that's very generally how the body responds. There are different time courses depending on the adaptation. I'll talk about that a little bit. You don't need to know any serious details, but the analogy I always go to is just your home. It's your house. If you're a homeowner, if you're a renter, who cares? Let the house leak, move out, right? Let the homeowner deal with it. But if you're the homeowner, this is fixing a destroyed home is much more expensive than preparing a house to withstand a storm or a flood or whatever. And so it's Stockton. It doesn't flood very often. Stockton seldom floods. What happens here is we get droughts. We have kind of these hot summers, and where the yard all dies up, and maybe there's a fire. There's always a fire, and the droughts and no water. And so that's really what threatens us. But if there's one year where the snow is melting in Tahoe or whatever, wherever it comes to Stockton from, and the Calaveras is filling up and the levee's going to break, and what do people do? This isn't going to happen again for 20 years. When's the last time we flooded? I don't know, a really long time. You just go buy sandbags. You make do in the short term, because that's sort of cheap. That's the cheapest option. You're going to get through it. It's a hassle. You don't want to do this every year, but 1 year, that's the cheapest thing. Now, if every single winter Stockton floods, you're not going to do the sandbags anymore, because it's going to end up, it's like an energy efficient light bulb. Takes a while to pay itself off, right? I mean, the sandbags are not an energy efficient light bulb, right? If you have to sandbag every single year, that's going to end up costing more than if you just dig your moat and whatever. So or build your wall. So that's sort of the time course, right, is you accommodate sandbag your house, right? Accommodate sandbag, and then you just adapt. Like, you know what? I got to remodel this thing. Otherwise, this is just going to be a disaster all the time. And so, if whatever the most routine and threatening crisis is going to be, damaging thing is going to be, that's what you adapt to. Now, in your body, man, it's expensive to recover. Get ill, get an illness of some sort, and preventive medicine, pretty cheap. Exercising and good food and whatever behaviors and go do your statins to lower your cholesterol. That's much cheaper in the long run, both financially and physiologically, in terms of the harm it could have to have some sort of infarction somewhere, and so preventive medicine is cheap. But you're not going to do preventive if your cholesterol's fine. You're not taking statins, so figuring out what the things that threaten us are most extremely and most frequently, what those threats are, and we respond to those specific stresses. Now, if what threatens us here is earthquakes, we're going to respond with like earthquake secure buildings. But if what threatens us is wildfires, which is what it is, earthquakes and wildfires, both of those things. It's probably going to be sinkholes soon because they're like draining. Listen to this only comes from podcasts from me. I haven't done the research about how much the farming in the Central Valley and the sinking Stockton, the sinking Central Valley. That there was one podcast that was talking about how we're like 10 feet lower. Don't quote me on that. Look up a reliable source when we're talking about things like the number of spider species in the world. I'm not a reliable source. When we're talking about things like the altitude in Stockton, I'm not a reliable source. But let's say these three are threatening us, and heat waves, okay, are threatening us here. But and droughts. Stockton is not a good place. But tornadoes, hurricanes, this isn't something that's threatening us. So we don't adapt our houses to these things. Our houses would be frail to hurricanes and tornadoes. But let's say you I don't know, you're like an LSU student, right? You're like Louisiana, and maybe you're gonna worry about like hurricanes. Yeah, so you have to adapt your living situation to the threats, but you don't adapt them to the things that don't threaten you. So we talked about this earlier, where if your biology can just tolerate something and it's not a big deal, just tolerate it. Get used to it. It'll pass. Okay. The obnoxious thing will depart in an hour or something. Oh, finally, that kid fell asleep, or the mother like put the pillow over the kid's face or whatever. You stop screaming. And but if it's just like you're gonna at least habituate. If you're flying every single day, screaming kids, it's going to be like the train that passes your house, and you don't notice them anymore, right? You're going to habituate to it. But if it's some sort of stressor where your tissues need to respond, then you are going to with serial exposure, with repetitive exposure, that's the only time you're actually going to adapt. And at that point, we talked about these two situations, right? You're putting on socks, you're turning on a light, and how we make these, we accommodate, right? We make these very short-term adjustments, pupil dilation, or just even nervous sensation, afferent sensation of socks. But if this is a more permanent stressor, let's say it's mowing your lawn, you go mow your lawn one time, the body's like, whatever, you did that one thing, you've never done this before, I doubt you're going to do it again, right? I'm conservative. I am not going to start translating proteins. I'm not going to invest in something you've done one time. Like if you're a parent and your kid's like, I want to play guitar. Well, like you've never tried, you've never expressed interest before. I'm not going to sign up for super expensive lessons. I'll give you like a little cheap $5 beginner's guitar from a garage sale, and we'll see what you do. If you practice your scales until your fingers are bloody, like, okay, now I'm going to get you the expensive, I'll get you a Martin and a good instructor or whatever. But so that's what the body's very conservative. It thinks you're like a little kid with a guitar who just, is never going to learn. But if you start doing this commonly, now the body adapts. And at this point, At this point, just like we notice changes in light, right, or changes in clothing or whatever, at this point, we're going to notice changes in behavior, right? We increase or decrease exposure, right? Oh, now we're mowing the neighbor's lawn too. Oh, all right, I got to adapt a little more. Or oh, we skipped a couple of weeks. That lawn got pretty hairy, right? That is crop circle lawn time now, and so we change our behavior, the patterns of exposure, and then that's when the body's really noticing that at that point. Now, the time course for these things, when does adaptation decay? When does it arrive? When does it decay? For some of these more natural things, not self-imposed, like you're lifting weights and getting your beast tattoo, and so not self-imposed, but nature, right? It's heat, it's altitude, it's something like that. There may be a slightly longer time course of decay compared to you stop working out and what happens to your muscle bellies, right? So this is heart rate adaptation. This is a meta-analysis looking at a bunch of different studies saying, how many days into it, what percentage of decay for the heart rate heat acclimation of so you become acclimatized would be out in nature. Acclimation would be in a lab setting, but let's just use them synonymously. You become heat tolerant, right? You adapt to heat, and you get sweat rate responses. You get cardiovascular responses. And what does the rate of decay look like? Well, I don't know. It's sort of something like this if we do a linear regression and look at it where 5-10 days, I don't know, or around 40% decay, something like that. This is I think they both say heart rate. So this one is sweat rate. So sweat rate right here says HR, just pretend that says S. But sweat rate over here, these studies, what we're looking at is like, it's been 18 days and there's no decay, but over here it's 180% decay and like, a week. And so I don't know, it depends on the conditions. It depends on the people that you enroll, but oftentimes, so take this with a grain of celery salt, oftentimes it's the last several days is really what your body's paying attention to. You did a really good workout. What day is it today? Friday. You did a really good workout on Wednesday. The body still remembers that. It hasn't forgotten. You're a little bit sore. There's an inflammatory profile that's lingering. The body is noticing that you worked out a few days ago, 2, 3, 4 days ago. The body remembers that. But the last few days, that's really what the body remembers. Just like, what did you eat for breakfast 4 days ago? Unless you eat the same thing all the time, or what did you how many people, who did you text at noon 5 days ago? I don't know, like, who remembers these things? Yeah. And I can remember what I had for breakfast the last couple days. That's about how much attention your body is assigning to things like resistance training and deliberate participation in things. But climate factors, environmental acclimation, this could be a couple of weeks that the body remembers, that the body's remembering some of these environmental, climate, sort of the natural world exposures, and retaining some adaptation a little bit longer, holding on to the sort of residue of its adaptation, sort of residual adaptation, that last little vestige lingers. And so environmental stuff, it tends, now again, a grain of Morton seasoning salt, celery salt, whatever, grain of some sort of salt with these, because it really depends on a lot. But depends. Let's get back to the idea of specificity. If you're stressing your body with road work, just go for your jogs, go running, go jogging, and what adaptations is the body making? Unless there's a bunch of environmental stuff, some heat things might linger a little bit longer. It's really the body's just, the last few days. So you're running. The body's responding. you're sedentary, your body's responding. And so you really have to be consistent with these things, and you can tell this effect. Just watch somebody get an ankle. Watch, like, if Kendall sprains her ankle, like Kendall has this massive VO2 max, and it starts to dwindle pretty quickly. And it'll bounce back. It'll bounce back pretty quick. But it's blood volume. You just start peeing a lot, so you pee out a lot of blood. Actually piss blood, but the volume, my hydration comes from somewhere, and blood volume. That's a nice pool of wet stuff. And like if you take a diuretic, furosemide or something, like you take a diuretic and you're going to piss a lot, and then your blood volume is going to be really low. But or the enzyme concentrations, I mean, this can decay pretty quickly, but there's a lot of this stuff is going to linger for a long time. And so what decays quickly commonly bounces back relatively quickly, but you see these fast changes because the body's just paying attention to the last few days. If you stress your body out on a golf course, if you're going golfing all the time, what adaptations does the body make? Well, ones that are going to make you a better golfer, whether it's endurance or focus or swing kinematics or whatever it is. That's what's going to change. And if it's a weight room, right? If you're stressing yourself out in a weight room, do you guys know Thorin from the weight room? If that is what you're doing, that's the only thing that's going to change, right? You're not going to become a better golfer by lifting weights. You're not going to become a better runner by lifting weights. You're not going to become a better anything but weightlifter by lifting weights. Now, can you become a better boxer because you can hit harder? Yeah, sure. But that falls into Edward Adolph's sort of overlap, right? So there are domains of overlap. You're a cyclist or you're a marathon runner. Okay, well, your heart needs to adapt. You need more mitochondria. You need more blood vasculature, right? Capillary density. You need a lot of that stuff is going to overlap in performances. But surprising how little. Otherwise, Lance Armstrong would have been a remarkable runner, and he was merely pretty good. But skeletal muscle, again, one of the most adaptable tissues, one of the most adaptable cell types is skeletal muscle, but we have genetic ceilings. And so just remember the duck and the chicken. Why is there no fat in there? Well, it doesn't need it. It doesn't need fat. It doesn't need this big, look how red that is. I mean, that needs to be aerobically fit, that duck. The chicken doesn't need aerobic fitness. It just needs to be eaten by people, right? And so that's really, it's actually probably a protective mechanism, because you need a lubricant to swallow it. This is delicious. So it needs to fly to escape. This just is like, don't eat me, I'm gross. And so, but there are genetic ceilings, and a mollusk, I mean, this thing is isometric. That's selective pressure for survival. That's why at the genetic level, right? Genetic adaptation, evolution, it's selective pressure. It dies if it can't isometrically contract really well. The frog, what does it die if it can't do? Leap really effectively. Now, we aren't that good of high jumpers. We aren't that good of, this person's doing isometric and trying to do a squeeze, I think. And so we're no mollusk and we're no frog, but we can develop, right? This guy, I don't know, where does he fall here? Is he like this? Maybe he's bronze medium, whatever. Yeah, he can move. This looks lighter, I don't know, but he can move. He could go tan, or he could become a little troglodyte and lose all sunlight for a while and get rickets, and then move in this direction, and his skin tone. But he's not going to have a different genome. He's not, was it like SLC24A5 or whatever that gene is, the primary skin tone gene? Google it, I don't know. But so we have starting points, and we can move within those starting points. Now, specificity. Let's talk about the specificity of specificity. Isometric exercise. Okay, you're going to get good at isometric. You're not going to get good at dynamic exercise, right? If you want to get good at dynamic exercise, do dynamic. Now, you can do, and I'll talk about this in just a second, you can do static and then move like 5 degrees and do static, and then you extend another 5 degrees and do static, extend another 5 degrees and do static, and train throughout the range of motion, and improve your ability to express strength throughout the range of motion. And that has, that's basically dynamic. But if you want to get good at isometric, do isometric. If you want to get good at dynamic, do dynamic. Is there some overlap? Sure, there's a little, but surprisingly little. Concentric and eccentric or eccentric activation, same thing. If you want to grow, just do this one. But if you want to get good at concentric stuff, right? If you want to athletics, a lot of it is concentric things. If you're a pitcher, you're not just succumbing to the ball. The only thing where there's that book, I Am America and So Can You. And great title. The book was surprisingly not that funny, but there's the only really funny section in the book was where he said, I'm unimpressed by diving as a sport, Greg Louganis and et al. And it's and et al. So and all. But he's like, you walk off the edge of the diving board and succumb to gravity. I'm unimpressed. But the eccentric loads, this is what's going to make you grow, but it's not really sports for the most part. It's really not sports. There's some isometric stuff if you're looking at maybe wrestling or football, something like that. Concentric, you're throwing, you're running, that's mostly what sports are, is concentric. So specificity of adaptation, what do you want to get good at? This will make you grow. This will make you throw stuff, whatever. And you'll notice, you probably have noticed that I always say eccentric. I don't say eccentric because there's no such word as eccentric. There's no dictionary in the world that says eccentric as a word. Just look it up. This isn't just me talking. Here's the Oxford English Dictionary, which is the only one you should trust. Anything that says Webster's in it, even Webster doesn't permit this, which is remarkable. Last time I looked, which was like a year ago. Webster's like a fake dictionary. It's a descriptive dictionary. It just says, here's how people are misusing words. Right, the Oxford English Dictionary, this is the prescriptive dictionary that says, here's what the word actually means. Use it this way, you dumbass. That's the Oxford English Dictionary that says, I set the rules. I am the referee. I am the umpire. That's the Oxford English Dictionary. It's the only one anyone should ever use. Webster or whatever, like here's what people use this word to mean. Like, well, this is, but they're using it wrong. But even like Webster doesn't permit like eccentric as a word. So I say eccentric, but then I'll commonly follow up with eccentric, since that's what everyone says. Which my hunch, and I don't know if this is true, my hunch is that at some point people were just emphasizing the words, and they said, okay, we have concentric and eccentric loads, and people are like, this sounds similar. I didn't write. I have no idea. Okay, we have concentric and we have eccentric. And people just started saying it that way. That's my hunch. Oh, there's a question. If we should just train for our goals, like if you want to get good at running, keep running, why do coaches buy into cross training? And I'm still reading the comments, maybe for unexpected situations that can arise in sports. I like that. Other than that, I agree with your question. So cross training. Now, you should train for your goals. And I like what Hunter said. So there's a lot of sports. When you have bodies competing against bodies, it gets weird. And I'll talk about this with Iowa wrestling. And I have this quotation that I've used before that's just sort of silly. I included all the ums and everything in it. But in wrestling, it's the stuff you do is weird. Okay, we have tennis players, Ross and Liam. So we have tennis players. Watch what people do in a weight room, the ranges of motion people go through in a weight room. And, it's relatively normal. It looks normal. And then look at like videotapes in the freeze frame when somebody's in some swing, and it's like crazy body positions in tennis. Just watch tennis and watch anything, skiing or whatever, but just let's talk tennis since we have tennis. But it's just if you can see me, I can't see any of you because I just minimize all of that. But if you can see me, the arms are like way back. And there's these ranges of motion that are crazy in sports. And you don't think about it until you watch in slow motion, like, whoa, look at the body doing that thing. And so I think a lot of the time, basic weightlifting and like, okay, we're going to do this exercise and we're going to do this exercise. And then when you watch what they actually do in real life, there's some crazy stuff that doesn't look anything like it looks in the weight room. And so you improve your strength in the weight room, but broadening the exposures, giving yourself broader stress through other ranges of motion and other speeds and other metabolic demand. So cross training, maybe there's a metabolic demand, and whether it's tennis or skiing or softball or it is Cameron plays water polo or baseball, and whatever it is, there's going to be metabolic weird things that arise that you don't really expect. And so my hunch is cross training. I'm just echoing Hunter. Unexpected situations. I think Hunter got it right. Where there are things that you don't really factor in when you do your baseline task analysis. Okay, what does your sport entail? Okay, you got to run this far, and then you got to, this is the range of motion, or this is the whatever sort of vectors, and this is how your sport moves. So let's train through those specific motions, and I think there's sports entails a lot when you watch it in slow-mo. My hunch is that's it, and possibly some people just do training wrong because they don't know what the hell they're doing. And so let's include running around the baseball field. I think that's super stupid, right? That's like ridiculous. So there's a lot of things that coaches will do that are just dumb, but there are a lot of things that I think probably are very useful if context matters, right? What does a sport involve? Well, what we say and what we think isn't necessarily what it involves metabolically or flexibly. So getting back to specificity of specificities, angular specificity, lots of commentary on this, where if she's doing bicep curls and this is isometric, right? This is live action, right? She has a webcam going, and this is, she doesn't blink. Her eyes are sort of closed. Nothing's happening, and she holds it there. She's going to get really strong. The adaptation is going to be a structural one in the skeletal muscle that's going to support this. It's going to support this in how the proteins remodel themselves. And a lot of what's going on is if you're doing it like 90 degrees, you might experience improvement from like 70 to like 110. So if you are, I don't know, 10, 15, 20 degrees away from your midpoint, you might experience some adaptation, but with each degree you move farther away from your training point, less and less adaptation, less and less evidence that you're actually training. Get 20 degrees away and I don't know, it doesn't look like you've ever trained before. And if you are more elongated, more stretched out, you might see a little bit more from a contracted state, a little bit more benefit. If you're in a very contracted state, you're not really getting much out of really contracted isometric. That's really all you're doing is improving your ability to do really contracted isometric holds. But let's say you're doing really contracted or really elongated. Well, what happens? Well, there's sarcomerolysis and sarcomerogenesis, right? So the sarcomere, you guys know what that is. The M line is right here, Mittelscheibe, right? German for like midline. Right? And then Zwischenscheibe is the Z disc. And so that's the M line and the Z disc. And so sarcomere goes from Z disc to Z disc. And the M line is not just some hypothetical space that's like the geographical center. There's lots of proteins live in there. There's structural proteins live in the M line, myomycin and M protein. And there's this whole matrix of proteins in that M line. But from the Z disc to the Z disc, right? All the actin and myosin are here. So like alpha actinin is the protein that holds the actin to the Z disc. This is your myosin, is this black thick one, and this is your actin right here. And there's titin, the biggest protein in the universe that anyone's ever discovered. Maybe there's something bigger on some like planet somewhere, but the biggest protein ever discovered goes from the Z disc to the M line. It's like 30,000 amino acids long. But the whole thing right here is like 2.5 microns. I mean, these things are tiny. And this shows, this is micrometers in length. So it's like 2.2 or so right here. Depends. It varies a little bit. Let's just say it's between 2 and 3, something like that, for the length of these things. And to put into perspective, a human hair is going to be, I don't know, 70. It depends whose hair. If you're like well conditioned and you have like thick, luscious hair, I don't know, you have 100, micrometers or something. But these little guys are tiny. But this is the functional unit of skeletal muscle, right? Skeletal muscle is just this longitudinal string of sarcomeres, one after another, 15,000 in a row or whatever. I mean, a lot of these things in a row. And for one muscle cell, a muscle fiber is a cell, right? One muscle cell is a fiber. And so cells are not these little tiny microscopic things, they're sort of relatively huge. They're not huge compared to like a dinosaur. But so your muscle, right? So these, when you get to these myofibrils, down here, it's just a string of sarcomeres. And you can insert sarcomeres or you can delete sarcomeres. Sarcomerogenesis, that's you insert sarcomeres. Sarcomerolysis, you lyse them, you get rid of them, you delete sarcomeres from that series. Now, if you delete some sarcomeres from the series, you're tighter, right? If you delete sarcomeres, now you're like, you can't extend your arm all the way. And so if you're constantly training up top, doing like isometric holds or doing, dynamic, but you're only doing the top half of the range of motion, you're going to wind up, especially concentric is going to be a stimulus for sarcomerolysis. And so you're going to promote sarcomerolysis, which is going to shorten the muscle, which means it's going to perform better in a contracted state. Now, if you're constantly training at a lengthened state, let's say you're doing isometric holds at a lengthened state, you're going to get sarcomerogenesis. Let's get some more sarcomeres in series. So we have, we used to have 15,000, now we got 15,200 or whatever. And now you can perform better at lengthened states because you're not stretching each if you have like a couple hundred more sarcomeres in series and you move your muscle, you like extend your arm an inch or whatever, each individual sarcomere doesn't stretch as much. Each individual sarcomere doesn't stretch out as much. If it stretches out too much, then the myosin can't reach the actin, right? If you stretch this out too much. If you're constantly working at lengthened states, myosin and actin can't reach each other very effectively. If you insert a bunch of sarcomeres, sarcomerogenesis, now you're training at lengthened states, and this thing isn't stretched out. Z to Z doesn't stretch out much anymore because you're distributing that stretch among additional sarcomeres. So sarcomerogenesis, sarcomerolysis, it's the adaptations when you start to see the structural remodeling of the tissue. There are some very specific things that you'll see like that. This is just, you don't need to know this. This is just a point of reference of how many sarcomeres are in muscle. So times 10 to the 4. So, tib posterior, 1, 2, 3, 4, right? Add 3 zeros. Sartorius, add 3 zeros. So 1, 10 to the 4, right? 1, 2, 3, 4. So add 3 zeros, 174,000 sarcomeres in a row. But medial gastroc, right? Add 3 zeros to that, and so that's now a comma instead of a decimal. 15,000 sarcomeres long. You can figure out how long a muscle, one of these myofibrils is if you just, let's just say it's 2.2 micrometers, something like that. So muscles getting longer at the structural level, at the level of sarcomeres, sarcomerogenesis. Muscles getting shorter, sarcomerolysis. And there's some evidence that eccentric loading, eccentric, right, loading, is going to be a stimulus for sarcomerogenesis, and that concentric loads are going to be more sarcomerolysis. But mostly it's just specificity of adaptation. Where are you training these things? Now, there's more to it than just sarcomeres.
Wait.
Yeah, happy to wait while I chew. Yeah, you talk while I chew.
So about the sarcomerolysis and sarcomerogenesis, it's just that they get shorter and longer. There's no, because on the last slide before that, you said something about deleting them. So are they getting shorter? Or are they being deleted, or is it both?
Deleting. Yeah, inserting and deleting. So Genesis, think like biblical Genesis, like on the first day, we create a sarcomere. You know, we and on the second day, let's create some more. So Genesis, generate, create. And so sarcomerogenesis, I think it was some other slide, whatever, maybe this, I don't know, whatever. Let's stay on this side. So we are inserting and deleting. So lysis, if you lyse something, you loosen, cut, whatever. ATP hydrolysis, you're chopping up your ATP. If you lyse anything and you're getting some loosening, some cutting of it. Analyze, you're cutting up, you know, a topic, right? You're analyzing, you're loosening, you're chopping up a topic. Literal root words of analyze. And so sarcomerolysis, you are getting rid of sarcomeres. And so when you do that, let's just make it around, it's 10,000 sarcomeres long, some, you know, myofibril, one of these little things. This right here is a sarcomere, and this is a sarcomere. So this is an M line, this is a Z disc, this is a Mittelscheibe, this is a Zwischenscheibe, right? An M line, Z disc, and so on. One of these things, let's say it's 10,000 sarcomeres long. Now, it's in his calf, and he's very plantar flexed here. So let's say he goes into some dorsiflexion. He's going to stretch out his gastroc a little bit, right? He's going to stretch out that calf a little bit. And if this one myofibril is, you know, if we have 10,000 sarcomeres in series, and he stretches it out, let's say it just stretches sort of a normal amount. But if he adds 500 more sarcomeres in here, now he has 10,500 sarcomeres to bear that load of stretch. So each one stretches a little bit less. Every single sarcomere stretches out a little bit less if you have more. If you go down to 9,500, lose 500 of them, and he does the exact same stretch with his foot, a little dorsiflexion. He does the exact same stretch, but he has 500 fewer sarcomeres. Each one of these things is distorted, distended, you know, stretched out more, because now 9,500 sarcomeres have to bear the entire stretch. 9,500 have to go the entire distance, as opposed to 10,000, as opposed to 10,500. So the number of sarcomeres you have in series, sarcomerogenesis and sarcomerolysis. Is that okay? Does that make sense?
Yes, that was perfect. Thank you.
Mm-hmm. Thanks for asking. So yeah, we have a bunch of sarcomeres in series. Genesis, lysis. Now, other stuff adapts too. And contact adaptation is one of the most sort of famous ones recently, because you look at something like boxing, you look at, you know, American football, where people are getting hit all the time. Even if it's like aggressive football, soccer football, right? If it is aggressive and people are just like tackling each other and kicking shins and stuff all the time, you will get contact adaptation. Now, what the hell is contact adaptation? Nobody really knows. I'll talk about it in just a second. But we become more resistant to injuries. At the start of a contact sport season, often what you see is that those are the injuries people are sustaining. Is like you get hit, and those are the injuries. At the end of the season, those aren't the injuries. You are well adapted to you know, having helmets ram into your thigh or whatever. So Mike Tyson probably said it best about contact adaptation. I mean, there's like real, you know, researchers, William Kramer being one of them, who talk about contact adaptation and potential, you know, extracellular matrix adaptation of things outside of the actual skeletal muscle that we're seeing being manipulated. But Mike Tyson we're not going to watch his boxing match, but this is from I have one of his boxing matches coming up, but so this is I actually want, is there any contact adaptation or research on concussions? Good question, for which I have no answer. Really good question about can people become more resistant to head blows? Now, I think chronically what we're seeing is probably the answer is no, because just look at the long-term consequences of this. I mean, just ask anybody in like any sport that wears a helmet. But in the short term, can you function? Can you take a head blow and then pass whatever athletic training test or something? I have no idea. Although I have published in concussion research, I really don't know anything about it. And so I'm not sure what the data that I've analyzed, which is 80 people or something. What I found was serial concussions end up with longer side effects. So people are there 6 months out from the concussion, and they're still having neurological deficits after 6 months, after 8 months, something like that. And the number of previous concussions was one of the predictors. I was doing regression modeling and kind of what is the duration of concussion severity. And what I was seeing was the more concussions somebody had, the longer the acute neurological deficit. But I don't really know anything other than what I was looking at. I read like no studies on it. I just had other people read studies, and then I did the analyses and wrote up what. So I don't have a good answer for you. I wish I did. Sometimes you get into like neurological things and you just get deficit, but it's possible. It's possible there is some contact adaptation with concussions. It's possible. I'm not sure. So I was in middle school. Mike Tyson gets out of prison. He has a fight with Peter McNeely. I had saved up my allowance for years, and I spent it on the fight, on whatever pay-per-view for the fight. And the thing lasted like seconds. It lasted like a second. It was like $50 of my like years of allowance. But he talks about this in his book, and he's in jail. It's Mike Tyson in jail. Nobody's gonna pick a fight with Mike Tyson. So he goes to jail, and it's just like a little sanctuary. Like nobody's gonna touch him. And then he gets out of jail, and he's like sparring with what he calls like some kid. I got to jail. But when we started sparring in camp in Ohio, I got hit with some punches from some amateur kid, and it hurt like hell. I wasn't accustomed to getting hit. I was supposed to box 5 rounds, but after 2, I said, that's enough for today. I'll be back tomorrow. Like, fuck, I couldn't believe that. It was a little amateur kid. It hurt me so bad. Should be badly. Should be an adverb there. It's Mike Tyson. Taking punches was definitely different from being in shape. At least he got different from, as opposed to different than, correct? But this is the contact adaptation. It's the best illustration of contact adaptation that I have ever seen. Is Mike Tyson can't take a punch, right? And with a lisp, we're just gonna watch just a part of it. I love. Look at Mike Tyson's eyes. There's Peter McNeely. There's Mike Tyson. I mean, the guy, and then McNeely starts giggling. I would giggle too. I wouldn't know what to do if Mike Tyson was looking at me like that. Whatever. We don't need to watch all those things. The fight lasts seconds. And this is a different one. So anyway, contact adaptation is when you look at Jay Hoffman. It's not the letter J, like Nathaniel's middle name. And William Kramer, and some of these people are talking about contact adaptation. It's like, there's probably something in extracellular matrix that's getting remodeled. There's a lot of glycoproteins and proteoglycans. Just this one's more carb dense, this one's more protein dense. This is a glycocarb, right? Protein proteoglycan, right? A protein and carb combined. So whatever one trails, whatever the last one is, the closer. is the, like if it's a concert, like who's the headliner, the person who plays last. So that the headliner of a proteoglycan is carb. There's more carb in this one, more protein. Who cares? So there's all this, collagen and in the extracellular matrix, and that gets remodeled with use and disuse and aging and contact, and so that's probably what contact adaptation is. Spinal. Okay, I guess we're gonna go back to that quotation.
I broke my back. What do you mean by that? Your back is broken. What, a vertebrae or what portion? Spinal.
Spinal. For the comment box, I had to honor it. So back to the fundamentals, right? The foundation, the fundamentals, and to some degree, right? That this is the only thing that really matters is the fundamentals. So if you are in art, right, you better be able to do realism, right? Don't start with cubism. Don't do like, Picasso. So if you start with Picasso, you suck at art and it's like embarrassing. Master realism first, and then you can go do your impressionist work and cubism and whatever versions of modern art. But you can always tell if somebody didn't master the fundamentals first. You can tell these people are like horrible at what they do. So let's go back to the foundation. What do we know about stress? Well, what is bad for us on some tiny little degree, like broccoli, sulforaphane, stuff like that. Mike Tyson punching you. So, stress is something that threatens us. Stress in some way threatens us. There's a fingerprint. There is an identity, a very specific, a very precise identity to every single. I realize class is over. Feel free to take off. We'll go for like 5 more minutes. There's a very specific fingerprint to every single stressor, and fitness is, can we deal with those stressors? Right? Fitness is not like, oh, I have good abs. Well, yeah, but like, are you good at life? Right? You have good abs, but does that mean that you're just like a fragile, piece of shit who can't contribute to society? Right? What do you mean abs? Like, abs is not fitness. Fitness is your ability to engage with and survive and thrive in, flourish in society and the environment and the world and all of its threats and stressors. You are robust and you can deal with this, and you're going to win against nature's threats. That's what fitness is. That is what fitness means. Now, we're not tardigrades, and so depending on the breadth of stresses, for us, it's not going to be hurricanes and tornadoes and floods and droughts. It's going to be squats and heat and hunger and cardiovascular stress as we're doing our running. The breadth of stress determines the breadth of adaptation. Which tissues chime in, right? Which tissues tissues participate and adapt. So let's get back to Katie Bowman. I had Move Your DNA in an earlier slide. Great writer, just the titleist. I wish she would have someone else title her books. Wonderful writer, though. And she had master's in biomechanics, and she talks in her, and when you look at her little kind of portfolio, she's like, the Tin Man, the Wizard of Oz, the Tin Man, his joints were on the outside, and I was so fascinated by that, by the biomechanics, that I had to pursue it. But this is what I think she was the first one. I think Katie Bowman was the first one ever to say this. She was certainly the best one to say it. Now, we talk about genetic adaptation in this class, evolution. What is the name that is synonymous with evolution? Nobody is going to say Erasmus Darwin, right? Did he talk about evolution? Sure, yeah. But we say Charles Darwin, right? Voyage of the Beagle was 1839. That was not the first commentary on evolution, though. William Charles Wells talked about it a long time before. There was a book, there was this timber book. It was like horticulture of naval timber or something. And you go to the appendices of that thing, and he was talking about evolution in that book. Patrick Matthew. There's all these other names for evolution that predated Charles Darwin. And who do we all associate with evolution? Charles Darwin, beautiful writer. Everybody should read Voyage of the Beagle. at some point. Amazing book. I mean, that was just poetry. Amazing book. That guy could write. And so he's a face. And so that to me is if this concept was introduced somewhere before Katie Bowman, I don't know it. Who cares, because he didn't write it very well. But we all know the nutrition label. Now, she didn't invent the nutrition label, but what comes next is I credit to her. So, but we know what the nutrition label looks like with fat and saturated and trans and cholesterol and sodium. And then you get down to like the micronutrients. You get macros up here, right? The total fat and carbs and protein and stuff with calories, right? And then down here we have the micros. But her concept was, it's the same thing with load profiles, right? The type of load, is this isometric? Is it dynamic? Is it concentric or eccentric? Is it the magnitude? How heavy is the load? What's the rate of application? Does the load get thrust on you quickly, or does it sort of gently apply itself? What is the direction? What is the duration of the load? And let's get down here into, is it variable? The location, you're doing bicep curls. Is it like, can you hold the weights like up halfway up your forearm? Is it way out there? What range of motion are you going through? What tissues are you using? Right? You're doing hammer curls. Are you doing, supinated regular curls? And so do we have some other agonists, helping out on that pole? And so all of these things matter. It's just like a nutrition label. All of these things matter, and our body is going to respond to foods very differently. Your body is not going to respond to a can of baked beans in the same way that it's going to respond to hamburger, right? Your body responds to these things very, very differently. And so the nutrient profile, the load profile, it's so different, and the body responds so differently. And to balance our budgets, we'll talk about this sort of soon, of the nutrition coming in and what's coming out. That matters, right? So the loads that we give our tissues really matter in terms of balancing our metabolic budgets. And this is that, if all you eat is Weetabix, if that's the only thing in your diet, you're going to have deficits, right? You are going to have nutritional deficiencies. Some vitamins, some mineral is gone, right? Protein, you're going to get kwashiorkor, right? You're going to have these deficits in your diet. It's the same thing with it. You can't eliminate everything. Oh, all I do is 100% resistance training, and I've never walked. My Fitbit says 6 steps at the end of the day, but I maxed my bench press 15 times. That's straight Weetabix. Maybe that's like straight beef or something. But the way the body responds, think of it as a trampoline. And you're distorting depending on where you jump on the trampoline, right? Are you like pointing your toes, you're thin as a pencil, and you're jumping right in the middle? Are you cannonballing? Are you starfishing? Are you jumping over here? Are you jumping over here? Are you lying on your side? What are you doing on the trampoline? Those springs underneath that little blue kind of like puckered tarp over here, those springs get distorted in a different way. They're deformed in a different way depending on how you jump. Now in the body, our springs are these mechanotransduction proteins. We have cadherins, that's cell to cell, so one cell communicating with the adjacent cell. Cadherins. Titin, that's that 30,000 amino acid long protein within the cell, so intracellular load. So intercellular means cell to cell, right, between cells. Intracellular, we're inside of the cell. Titin goes from the zetas to the M line. That is a sensor. It's a protein that is sensing the nature of loads. And then integrins, the most studied, most understood, and probably the most important one, extracellular, meaning extracellular matrix, what we were just talking about with all those glycoproteins and proteoglycans, that environment immediately outside of your cell, your yard, right? It's not like the street would be like your blood supply, like your capillary beds, and that'd be like the street. Your yard would be outside of your house, but not clearly, out in the street. So that would be like your extracellular matrix. Is right outside of the cell. So extracellular load, that's integrins, another protein, and that is, what is the environment like right outside of the cell? Let's relay that information inside of the cell. The nature of the load, what characteristics of deformation is our cell experiencing? Let's relay that information into the interior of the cell so we can translate proteins accordingly. We can change behaviors. We can adapt accordingly. So every single deformation of the trampoline, every distortion of a spring changes the mechanical signaling, the cell's reception of that signal, and that signal is mechanotransduction. It is sent into the interior of the cell, and it affects things like mTOR, right? Mammalian target of rapamycin. You can say mechanistic target of rapamycin. That's fine. But mTOR signaling, which is let's make a bunch of proteins. Let's do that super expensive thing. Let's call it half of the cell's metabolic expense. Let's use these proteins, cadherins and titin, especially integrins, to inform our cell how we're jumping on the trampoline, to say nature of the stress, right? Here's what we need. Here's what needs to happen. And then, not all activities are going to be the same. If you're Cameron and you're in the water all the time, that's not helping bone density. Cycling isn't even all that helpful for bone density. Running, all that impact, that's helpful for bone density. And bye, Genevieve. This is my farewell to you. And we're going to get into this too. Neat. Non-exercise activity thermogenesis, other types of things other than exercise. So one of those earlier questions, who asked it, Cameron, about should it train for goals or the cross training, and then what Hunter said of unexpected situations. Exercise shouldn't account for everything. And so one of Katie Bowman's lines is, in the same way that supplements should not be the bulk of your diet, exercise should not be the bulk of your movement profile. We should have a diverse movement profile to inform, to diversify our profile in that load, so our cells know how to adapt. So this, right? We need an appropriate amount of stress. And there are consequences. Let me just very briefly, I realize I've already gone a lot more than I said I would, but I'll very briefly go through this. The consequence of telling a little kid, go throw 80 pitches. Well, what happens? Specificity of adaptation. It's a single direction. You go forward, 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 forward. What's the consequence? Those muscles adapt. These repetitive patterns cause specific adaptations, right? Specificity of adaptation. You're not going to do this comprehensive adaptation where the antagonist muscles are responding just as effectively. And but so what you end up seeing is this opposition of forces where there's a relative weakness in some direction, right? There may not be an absolute weakness. These are athletes. They're going to develop force in one direction, and the opposite direction isn't weak. It's no weaker than they were when they were a beginner, but it's weak relative to the other direction, right? And so you can wind up with injuries because of disproportionate capacities, right? You have these oppositions of forces that are not equivalent. They're not what they're supposed to be. And so considering how we train shouldn't just be pure specificity for performance. We should also consider balancing with sort of injury prevention, some of those preventive strategies. So take home message: specificity. This really is the most important thing, the foundation, the governing principle of stress physiology is specificity of adaptation. But number one, there's no source of stress that isn't unique. Every single stressor in the universe is unique. Whatever it is, isometric exercise, running at a 5-minute mile, running at a 5-minute and 10-second mile, running at a 6-minute mile. These are unique stressors. Number two, this is a Hungarian stamp from like 2007 that had Hans Selye on it, trying to look contemplative or something. But despite Selye saying, oh, general adaptation syndrome, not true. Right? We adapt so specifically to the stressors, to those unique stressors. Number three, everything adapts. It's not just your muscle. Everything adapts, and it's going to, every cell, every organ, every tissue, every body system, everything is going to adapt to whatever the stress is it is being subjected to. Those adaptations are for self-preservation. Will they make you improve? Yeah, sure. But for self-preservation, that's the goal, is self-preservation and ultimately reproduction. All living things, everything, you Pokemon, everything, your dog, everything adapts constantly to better tolerate its environment, to be more compatible, to be more fit, to be more suitable to its environment. And corrective exercise, stuff like physical therapy, that's just manipulating biological stressors. That's all it is. There's nothing but that. It is mechanotransduction to heal, to elicit a response that you want. And there's a lot of all of these exercises and stretches that an occupational therapist or a physical therapist is doing is just manipulating stressors, just manipulating loads to elicit a very specific effect in the human body. And we'll get into mechanotransduction a little bit. That's more muscle phys, so we're not going to cover it too much here, but we will get into that a little bit. And oh, there's still some of you there, and there's a little baby Cameron. Okay, so what questions do we have?
Can you put those last two, the last slide up where the take home point so I can go? That counted as a question.
There was a question. So yeah, the last two. So do you want me to go from the top? Do you want me to go from the first, from number one again?
That would be great.
Okay, so this is a summary of the fundamentals of stress physiology. We're however many lectures in, 4, 5, something like that, lectures in. And all we've been talking about is the breadth of stress, the nature of stress, mostly nature's stresses, and how we respond to it. We haven't really gotten too deep into, physiological things or specific stressors. This is the general, this is like the Cellier general overarching premise for the entire class right here. What is stress physiology? Well, every single stress, the world is filled with stressors. There's a billion, however many stars there are in the sky, right? However many, grains of sand in Arabia or whatever, that's the number of stressors that we have. I mean, it's just everything is a stressor. You listening right now is a stressor. There's like 50 stressors you're enduring. It's postural stuff, alertness things, stress on your ears as you're listening. There's any number of stressors you could be experiencing right now. There could be emotional stresses you're dealing with. The world is filled with stressors. Every single one of those stressors, everything is unique, right? There's a unique fingerprint. It has its little barcode, right? It has its PIN, right? It's personal identification number. Every single stressor has a unique address. We do not respond generally to those stressors. When our body, our brains and our tissues and our body systems, when those respond, when they receive stresses, when they encounter stresses, they do not receive them generally. Now, very acutely, maybe there's a little bit of ambiguity there, right? So that general alarm reaction, Cellier's general alarm reaction. All right, sure. But the actual adaptation, what we do in response to those stressors, very specific, and it's obvious when you just even think of the acute stuff. It's light out. Okay, do you start sweating or do you constrict your pupils? Like it'd be ridiculous. Like, oh, maybe if it's hot out, do you like dilate your pupils or do you sweat? Even the acute stuff it gets pretty specific if you think about it. But in general, we'll talk about the hypothalamus and stuff. And so a lot of this hormonal response to all stressors looks the same, general alarm reaction. But infinity stressors, they're all unique. We respond uniquely to each of them. Every tissue adapts. That's number 3. All of our tissues are adapting. Even cartilage, which was just like dead tissue, even that adapts. Cartilage even adapts. Everything adapts very specifically according to the specificity of the stress. All of these stressors are aimed at self-preservation, right? Nature's first law. I mean, we've been saying this thing for centuries. Nature's first, we've been saying this since S's were written as F's, since English was like an unreadable language by today's standards. We've been saying this. nature's first law is self-preservation, replication of the genome, maybe the actual first law, but nobody back then knew what the hell a genome was. And then everything spends its entire life, because what is self-preservation? Becoming more fit. Let's be super fit. That's what self-preservation is. Let's be as compatible with the stressors and loads and sort of punishing environmental contexts as we can. Let's befriend danger. Let's befriend pain. Let's befriend threat and stress and loads. Let's befriend all of these things, and we just love them, and they love us. That's what fitness is. And every creature, the skunks who rifle through your trash at night, and the ants who kind of sneak in through the cracks in the walls, and people and elephants, and we all are constantly adapting in the direction of fitness for self-preservation. And then when you get into fields that are, the recovery center, right? The recovery center, what needs to happen there? Well, we need to alter the load profile so that people recover, right? Alter the presentation of stress, alter the environmental context that people are living in or experiencing, or even just being treated with acutely. Alter those stress profiles in a therapeutic way. And we have an entire industry of occupational therapy and physical therapy, two industries, where it's just 100% mechanical signaling, mechanotransduction. So that's what that one is. Was I okay to stop the share?
That was solid. Thank you.
Okay. Liam, how's your morning going?
Bit of a grind. It's Saturday here, so
oh, it is, isn't it?
I'm ahead of you guys. Yeah.
Early Saturday. All right.
Yeah, I kind of forgot that last night, and then realized I need to get to bed. So
yeah, you got a weird schedule.
Yeah, it's very weird. I've got two questions for you. Firstly, I want to ask, not so much a question, but just kind of confirming with you. You talk about adaptation and how the body's conservative in its approach, but I'm fairly sure from memory we have a sort of adaptation memory within our body. Like somebody who's being very muscular and strong kind of has a few intracellular proteins or satellite cells or something or other that'll allow them to get back to that level quicker than someone who hasn't been there before. So is that just like I guess, is that just some sort of advantage to have that memory of adaptation?
So there's a lot of explanations for that. If you just look at Muscle Mag or whatever, they're going to say things like, Liam, are you still? Oh, there you are. Everyone just shifted. I'm like, you asked a question and then left, because you shifted on my screen. Like, where'd you go? If you read some of these kind of unscientific sources, it's like, oh, you're stretching out, the elastic tissues, the mesiums. Everything's contained, right? You have like a epimesium around the whole muscle, and then the paramecium around the fascicles, bundles of fibers, and then the endomesium around the individual. So you have all these you have all these sheaths around everything. So you stretch out the sheaths, and then the walls are forever bigger, which just gives you room to grow. So I don't think that's sure, a little bit, fine, but when you do, let's say somebody does anabolic steroids, androgens, or you're just working out really hard as a teenager or something, and you can hormonally kind of support this, you're going to see a lot more nuclei, myonuclei. And even just go work out your supernatural, and you're working out now, and you're still going to get this, just not as pronounced, just not as quickly, and not as many. But go do resistance training, and you're going to increase the number of myonuclei, muscle cell nucleuses. Huge cells have a bunch of nuclei. Cancer is multinucleated. Muscle is multinucleated, big cells. And you can only grow in accordance with the number of governments you have. So I don't know what the Australian kind of political system is like, but so I'm just going to use the U.S. because I know a little bit about that. Every
those that argue, but yeah.
So but like every city, you have your mayor, you have your corrupt mayor in every Californian city, and every state you have your governor, right? And then we get into there's the federal government, but there's state and city governments, and there's governments all over the place. If it were just federal government, right, the U.S. would not. I mean, it would work even worse than it does now, which I don't even know what that would look like, but it would work even worse. You need local governments to oversee spending in a local area. Imagine if Donald Trump were like, okay, I'm going to take over all funding and sort of expanse and architecture and kind of civic everything in Stockton and in every other city in the U.S. I mean, let's just go every state and every city within those states. Imagine if Donald Trump were the decider for all of that. Yeah, I mean, let's all move to Uganda. I mean, it would be ridiculous. In the body, it's similar. We have to have every single city has a mayor. You have to have your government, which is the nucleus. And so protein accretion is not going to happen without appropriate numbers of nuclei. So before you see a bunch of hypertrophy, nucleuses, right, start getting deposited. Those don't really go away. And so now you atrophy. Well, now you have this just tissue that's dense with myonuclei. You retain a lot of those nuclei, and so now when you decide you atrophy, you stop exercising for a few years, you come back to it, you have a government that's supportive of growth. At that point, you have a government structure already established that's permissive of growth. So that's probably the biggest reason why you would be growing. That takes time, the first time around. And is there other stuff? Sure, yeah, but at the gene level, I mean, that's really what's going to determine somebody's response to exercise.
Yeah.
Does that answer your question?
Yeah, that answers my question. Yeah, I'll hand it off to someone else. Anyone else says.
Did you say you had two?
Yeah, but you kind of answered the other one as well. So
okay.
Yeah, it's all good.
I just had a question about the comp questions.
I'll send those out. I'm sorry.
Okay.
Yeah.
No, it's okay. I was just wondering.
Yeah, it's going to be super easy because you just do it at home.
Okay. Good.
Yeah, comps are super easy right now. So I've been lazy. I'll get those out this weekend.
Okay.
I'll send everyone this weekend. And you have nothing to stress about. You wouldn't anyway because you're Kendall. Yeah. But your roomie. I talked to your roomie today.
Oh, which one? Bethany
Hammer.
Yeah.
Yeah.
Her and Ryan are my roommates.
Oh, Ryan's great. Yeah, right, like female Ryan.
Yeah.
Right, Martinez. What's her last name?
Yeah, Martinez.
Yeah, they're both great. You've chosen roommates well. I think. I don't know. I don't see what they do to the kitchen.
Yeah.
But
no, they're great.
Okay.
They do their dishes. It's awesome. Yeah. Okay. Well, thank you.
Mm-hmm.
See ya.
See you. Anyone else?
Did you already send the check my email again or no?
The papers? Yeah, they're not in your inbox yet.
Right.
Is that what you're looking for?
I was like,
I said I would send them, and then
to search more or but it's fine.
No, they're coming. They're en route, just not digitally. They're en route emotionally.
Okay.
Everyone else doing okay in life.
Yeah, I guess I have a random question.
Okay.
You said like there was a book that everybody should read one day. What was the book called?
There's a bunch of books I think everyone should read someday, but give me a context.
I honestly don't remember. You just I think something about a voyage or something. That's
Oh,
all I remember.
yeah, the Beagle.
Beagle.
Yeah, the Voyage of the Beagle. So Charles Darwin's Voyage of the Beagle. It's his first book where he basically outlines evolution, and you can get. There's an audiobook. I did it on audiobook, and Richard Dawkins reads it. He does a really good job reading it, and it's beautifully written and really outlines. Even when you look at, and I think Dawkins talks about this in the book. I think he talks about it in this one, where Charles Darwin kept rewriting things and trying to address the sort of population's criticism of his work. But the population's criticism of work was just stupid, right? He was a genius, and the people who were attacking him were idiots, right? And so he was trying to have this conversation and explain, so as he was doing these re-releases and kind of new iterations of the book, it just got worse. The first edition was a masterpiece, and then everything else you ignore. And so the version that Richard Dawkins chose to read for Audible was the first edition, and it's such a good book. I mean, don't feel you have to do it right now. It's not very long. I mean, but at some point there are a few historical science books. Actually, Dawkins has one too, The Selfish Gene from the 70s. Brilliant. I mean, he talks about the brain as like transistor radio. I mean, so some of his analogies and examples and stuff are a product of the times, but essentially nothing else he said has aged a day. I mean, it's like the rest of the book doesn't even have gray hair yet. And other than a few references to contemporary things, which in the 70s don't make any sense to today. They make sense. They're just sort of silly. But yeah, so there are a few scientific historical books that are just brilliant. And I think they should be on people's shelves and have been, read at least once.
Yeah.
I have a memoir recommendation if you like those.
Good. I need to read, yeah.
It's called Hillbilly Elegy. They're actually making a movie about it on Netflix with Amy Adams and Glenn Close, but
I saw the movie.
Friend
it came out.
What?
The movie came out. I saw it.
Oh yeah, well, I'm reading the book right now because my friend, we're family friend because he's in his 50s or whatever. He's like, I'm telling you, you have to read this. And then 3 months later, that's when they announced the movie's getting released. So
I'm sure the book is way better.
Yeah, that's what he said. He said the book was much better than the movie. I haven't seen the movie yet.
That's usually really good books tend to make poor movies and vice versa. Because it's just capturing a really good book. You can't really do it justice. And then everyone's offended. Like, wow, how dare you? But if there's something, if it's like Charles Dickens, paid by the word stuff, and you have every book is 10 times longer than it should be. It's like, why is this book so fucking long? It's like, well, because you're being paid by length. Those, I don't know why they don't do the rest of Dickens's books as movies and Pickwick Papers and whatever, all that stuff, because they're like, you can cut 90% of it and it would enhance it. And that's what, so I think that stuff would be better for movies, but I'm guessing this one would be better in book form. It was cute.
Oh yeah, no, I'm in the middle of the book right now and the book's really good, but I haven't finished the book yet. So far it's pretty good, but you said that and I just started laughing because I was like, yep, I'm reading a memoir right now.
No, yeah, that's funny, the memoirs, but it's interesting reading either people who I admire, who how did they do this? Well, the life of a genius, what does that look like? And reading that stuff, or reading people whose lives are so tragically worse than mine. Those are interesting too. And case in point, that one I think would be an interesting one. But yeah, people who are just, man, the struggle is without end, and I don't know how they cope with this, and wow, the world is this bad. So some of those memoirs are fascinating. Those are the two worlds that I prefer to read. What do you guys got lined up for the weekend?
I'm getting the vaccine.
Oh,
Really?
Yeah.
How?
Yeah, Pacific's doing the Pacific's allowing certain staff members, so like first responders and then public safety. So I was lucky enough to get an opportunity. So
No, keep me posted.
yeah, I will.
yes, I think I just got that email today too.
I don't know if I grow if I grow a pair of wings.
Yeah, if something cool happens, if you become like Batman or something.
I think it's the Pfizer one as well. So a
Okay.
little more confident in that one than Moderna, but both seem to be pretty so far.
Okay.
Yeah, that's cool.
My dad got the Moderna, but that's the one in 2 stages. I can't remember if Pfizer's just the one go because they've only allowed.
I think it is.
Yeah,
It's 2 stages.
Okay, cool.
My dad said, like, him and staff, they said, like, it's like a normal vaccination, but the only thing is, like, their arm was like very sore afterwards, like way more sore than when you get the flu shot or something.
I know. I think the worst shot I've ever received was probably like way back when like the HPV shot was required for like 7th and 8th graders or some shit like that, and it was like one of those things of like for a couple of days and then it like got back. Cool.
Rabies shot. It was 5 of them.
Oh my
6
god.
of them.
You said you got a rabies shot?
Yeah.
Not like in the stomach, not that one.
No.
Okay.
Now they do it based on. So my brother had like 4 because based on body weight, and my brother's skinny, and so he was like, "Yeah, I got 4," and I'm like, "Fuck you, I got like 6." So I had to go. It was like 1 on each arm, and then like in the thigh, and then in the ass, and it's just like bend over. I'm like, all right.
Yeah, I think proportionate drugs and supplements and stuff. You ouch. I think if you're Nathaniel.
If they did that for all vaccines, because I'm probably just above the weight of like every category that I've grown up in. So yeah. But we'll see. I've heard some interesting after effects of the vaccine from other people, but we'll see.
I haven't heard anything. What if people are? I mean, it's just like soreness, or is it like?
So my dad, I think the first dose, he had quite a few headaches, and he was slightly unusual, but it like went back to normal after 2 weeks. The second round, he was just he had like a headache the day after, like a hangover, but he was fine by like the evening. And then another friend of mine experienced chills, like severe chills for a few hours, where it was almost like they couldn't stop shaking after they got inside. But again, that could be another environmental factor. But yeah, I haven't heard anything else bad. But I'm just going into it like it's a usual vaccine, where if I do feel a little sick, it's normal, and just yeah.
I heard the
Moderna. No government trackers in the vaccine either. So
I love all those conspiracy theories.
Yeah,
I already got one in me already. So
I work with longshoremen, and longshoremen are not the most educated bunch, and so really nice guys, but I just hear a lot of like, "Oh, they're tracking us." I'm like, "You carry your phone on you, right?" They're like, "Yeah." I'm like, "How many times have you hit terms and services?" They're like, "I'm like, it's a lot easier just to fucking say, here's an app."
Yeah.
Terms, and then track you there. It's like, why do they need to go through the trouble of like
injecting you? Yeah.
Your body's just gonna reject whatever you put into it. Like you're gonna put a tracker in your body's gonna be like, "Oh, fuck you, no."
If the pandemic taught me anything, it's how old school some of my family is. Like my grandpa, he was like, "Oh, I'm probably not gonna get the vaccine," and I was like, "You have like gout like twice a year though, so it can't be that bad." And he's like, "Oh, I'm like 86, 87, I'll be fine." I'm like, okay, well, you're the one who says drinking cold water after a hot meal will give me cancer, but I don't see his doctorate anywhere, but it just cracks me up.
A buddy of mine from back home, he called me up, or we were talking on the phone, and I'm like, "Oh, you gonna get it when it comes out?" He's like, "No, I don't trust it." And I'm like, "What do you mean?" It's like, "I just don't know what's in it." I'm like, I saw you do cocaine in high school. Like, like,
You have no idea what's in that. Like, you know, they
Really?
cut it with government trackers. The cocaine.
Yeah.
That's how they get you. The credit card you use, they trace that. But
No, but he was just like, yeah, it's like I see you do cocaine that you've gotten from like a stranger that you like your buddy recommended. It's like,
Yeah,
really?
yeah, you have no. I mean, who knows what the hell's in that?
that just reminds me of like my favorite Jensen quote of all time: "Anything can be a superfood. Heck, meth could be a superfood."
129 days.
Oh, yeah. Oh my gosh, yeah, those are the good old days when. I just remember, if you haven't seen a body dredged out of the Calaveras, you haven't lived the full Pacific experience. It's literally like, after like all the closures happened, they found a body in Calaveras, and I was like, cool, the prophecy has been fulfilled.
That's funny.
Well, Calaveras, if you translate it, means River of Skulls. So I guess that makes sense, right?
It's really great because, you know, we have a building named after it where people sleep and, you know, cohabitate. And I just think it's sort of like an ominous type of, like, what if you lived in like Southwest, but it really meant Death Hall, you know, like, well, how are you gonna equate to that, or what does that mean?
Yeah.
I gotta go, but I just wanted to say have a great weekend, guys. And Courtney, thank you for all your help with everything. I feel like I like email you in panic sometimes, so thank you. Thank you for your help.
Thank you for your help.
Bye, Lexi.
Bye, guys. Have a great weekend.
All right, I'm gonna get out of here too.
I was gonna say good luck with your flu shot. Good luck with your vaccine, the COVID vaccine.
Thanks. I'll ask if they can put it in my eye. No, I'm kidding.
Bye, guys.
Bye-bye.
All right, I'm out of here too. Go enjoy your weekends.